Today I'm going to be doing an experiment using the FR7.5G compressor in my water chiller system. So what I'm doing first is looking at the data sheet. I'm probably not doing this right, but I'm looking at this one here. We're looking, actually, I think about the ASHRAE one. I think that's the one I need to be looking at. And I want to operate the evaporator at 0 degrees C, so the capacity in watts is 506. This might not be correct though, because this is using R134A, not R290, so it might not actually work as expected. So this is CCOP cap cell, so, and I've got the data in it just now. And basically we're looking at these were already in there, but we need to look at the test conditions for ASHRAE LBP for 0 degrees C. Should be down there. That's one we're interested in. And we're making sure that matches up with this. We're looking at condensing temperature, it's 55. Evaporating temperature, that I want it to be 0, and the return gas temperature, that must be the suction gas, so that's 32, so that's fine. The only values I had to change was my evaporating temperature and heat load, so I need 1.34 meters of 0.9. I've got that here, it just needs to be cut correctly. So once I get this all built, we'll see how it actually behaves in real life. So if you just search Google for CCOP cap cell, you'll be able to find this. I've got also here a filter dryer, but I won't be using this one until I'm ready to build a finalised system. I will be housing the condenser and evaporator within water filter housings because they get a real good seal. Another reason I'll be changing over is because these containers, well, this one here is split and it's leaking. And that's a water filter housing, so that'll be a lot better. Now I am just recovering the refrigerant out of the old system here. So once the power consumption drops quite a bit, I'll know it's just about done. Because if I turn this valve off, it goes down, but there's still refrigerant coming out of the system here. You can hear a little hiss as well when you open it, so it's got a lot while to go, and this is sitting in cold water, so the refrigerant will condense easier into it. And it also helps to prevent liquid from backing up in here, and then all coming out when I take the hoses off. The old system and this compressor here has now been purged with carbon dioxide. I don't have any argon or nitrogen, so that's what I can use. And the reason I did that is because just so there's no propane left inside it, because I don't want it to explode when I start soldering. So here's my 1.34 meters of cap tubes here prepared. This is full of carbon dioxide just now. Under a little bit of pressure, and it's actually getting a little bit cold on this side, and very slightly warm on this side, so it does refrigerate very slightly. But I would imagine for you can use carbon dioxide as a refrigerant, but you need a very specialised compressor for it, with the high side probably going up to well above 1000 psi. And you probably need a very thin capillary tube as well. But due to the high pressures, it's not used as a refrigerant very often, as far as I know anyway. So when I was letting that out, you can actually taste carbon dioxide. It's kind of like, well, you know when you drink just carbonated water, it's just kind of like that. And it does sting your nose as well, so you don't want to be breathing this stuff in. Breathe it in too much, you'll probably faint as well. That's all done now, as you can see. Very short capillary tube, and just need to get under vacuum. I'm building the vacuum pump just now. That's how much capillary tube was on the old one, and it was just causing the evaporator coil just to freeze up and not allowing it to move all that much heat. So it wasn't really ideal for like chilling water. You could use it for cooling down antifreeze, I suppose, but it's not suitable for water because it was just freezing on the evaporator all the time. So with the shorter and slightly thicker inside, shorter and slightly wider inside capillary tube, 0.9mm, it should be able to move more heat, but it won't go down to as low a temperature. Now everything has been vacuumed down. So this is the first compressor here, and then I've got the second one there just to increase the strength of the vacuum. And then once it's vacuumed down, I'll just pressurise it slightly with propane from here, and then suck all that out again just to make sure it's fully purged. That's the power consumption of this compressor that's under vacuum just now, and that seems about right. I'm going to leave it for longer under vacuum. So I just let a little bit of propane into it. I'm just vacuuming it out again. It wasn't very much, just a little bit. As you can see, it is still coming out. I've noticed that if you put propane in it, it takes a lot longer to vacuum down than it does with air. Probably to do with it being more dense in there. Not that sure. So I've got it down to quite a low power consumption, and I'm going to turn all the pumps off now and add in propane just to get it to a positive pressure, so I could take the hose off, or I could just charge it through this compressor, because those are both the suction, so I think I'll just do it that way. The reason I'm doing it that way is just so not to get air into it if I take this off and it's under vacuum. So turn the vacuum pumps off. Refrigerant going in. It's making all the right noises anyway. I'm getting chilly cold. The condenser's getting warm too, so that's about right. Yeah, it's getting very frosty there. So So I know it's under a positive pressure because I could still see the refrigerant coming out there. So just took it off and I'll just connect it directly to the bottle. Makes it a lot simpler. So charging hose is hooked up, not one bit of air got into there, so that's good. So I'm just going to give it a while and add more refrigerant to it until it starts consuming some serious power. Well, the correct power. So looking at the table, the maximum power that this compressor should ever consume under any conditions is 298 watts. Now in my one that I've designed it for, it should consume about 240 watts. That's obviously at standard test conditions. It will vary quite considerably, but as long as I don't go over that, it should be okay. Well, that's all working now. Just unplugging the water pump. As you can see, the power consumption goes up. And it's doing a really good job. This water here is getting really cold now, so and this water's really warm, so it's working. The pressure's pretty warm too.